Welcome to ZoomInData, your go-to channel for in-depth Azure Cloud, Serverless, and modern development interview preparation. In this video, we dive deep into the top 25 Azure Functions timer triggers interview questions for 2026. Perfect for developers, architects, and anyone preparing for AZ-204 certification or building scheduled serverless workloads. We cover timer trigger fundamentals, NCRONTAB syntax, time zones, singleton mode, overlapping executions, dynamic schedules, run-on startup, monitoring, cost implications, testing, isolated worker support, and best practices, all explained in clear, interview-ready technical language to help you confidently ace your next interview. 1. What is a timer trigger in Azure Functions? A timer trigger is an event-driven trigger that executes a function on a predefined schedule using NCRONTAB expressions. It enables recurring tasks such as cleanup jobs, data synchronization, or scheduled reporting without external schedulers. The trigger fires based on the configured cron schedule, supporting both fixed intervals and complex patterns. Timer triggers are supported in all hosting plans and run independently of other function invocations. 2. Explain NCRONTAB expressions. NCRONTAB is Azure's extended cron format with 6 fields: second, minute, hour, day, month, day of week. Seconds field, 0 to 59, allows sub-minute precision, unlike standard cron which starts at minutes. Supports standard cron syntax plus Azure-specific extensions like N for intervals and for lists. Time zone is UTC by default unless website_time_zone app setting is configured. 3. How do you handle time zones in timer triggers? Timer triggers use UTC by default. Set website_time_zone app setting to desired time zone, e.g., India Standard Time. Time zone affects schedule evaluation. NCRONTAB expressions remain in UTC internally. Daylight saving time transitions handled automatically by .NET time zone data. Use explicit UTC offsets or named time zones for consistent scheduling across regions. 4. What is the default schedule if none is provided? If no schedule is specified in the timer trigger attribute or function, JSON, the function does not run automatically. A default schedule must be explicitly defined. No implicit fallback exists. Common default for testing is 0/5 every 5 minutes. Omitting schedule results in a non-executing function unless manually invoked. 5. How do you make timer triggers singleton? Singleton mode ensures only one instance executes the timer function at a time across the scale-out. Configure in host JSON under singleton section with lock period and listener lock period. Essential for stateful timer tasks to prevent duplicate executions in distributed environments. Recommended for timers that update shared state or perform non-idempotent operations. 6. Explain the use of %schedule %app setting. %schedule % is a placeholder app setting that allows dynamic schedule configuration via external settings. Function uses the value from app setting, schedule, instead of hard-coded cron expression. Enables environment-specific schedules, e.g., dev every minute, prod hourly. Value resolved at runtime. Supports standard NCRONTAB syntax. 7. How do you handle overlapping executions? Timer triggers do not prevent overlapping by default. Concurrent invocations possible if schedule fires while previous run is active. Use singleton mode to ensure exclusive execution across instances. For non-singleton scenarios, implement idempotency or check last runtime. Long-running timers in consumption plan may time out. Use premium for unbounded duration. 8. What is the maximum timer interval? Maximum interval is 1 year, approximately 365 days, due to NCRONTAB limitations. Practical limit is 60 minutes in consumption plan due to execution timeout constraints. Premium, dedicated plans support longer running timers without timeout restrictions. For intervals longer than execution timeout, use durable functions with timers. 9. How do you pass parameters to timer functions? Timer functions receive timer info parameter containing schedule status and is passed due. No direct parameter passing from schedule. Use app settings or external config for dynamic values. %schedule % and other expressions resolve at runtime for flexible configuration. For parameterized scheduling, use durable functions orchestration. 10. Explain timer trigger status storage. Timer status stored in Azure Storage Table, Azure WebJobs timers, for tracking last execution and next schedule. Ensures reliable scheduling even after restarts or scaling events. Lease mechanism prevents concurrent scheduling across instances. Storage connection string configured via Azure WebJobs storage setting. 11. How do you debug timer triggers locally? Run locally with func start. Timer functions execute according to local schedule. Use is past due property to simulate missed executions. Debug breakpoints hit at scheduled time. Adjust local time zone for testing. Log stream shows execution details during local runs. 12. What happens if a timer function throws an exception? Exception logged to application insights and console. Function marked as failed in run history. Timer schedule continues normally for next invocation unless singleton lock is affected. No automatic retry for timer triggers. Implement retry logic in code if needed. Failed executions visible in monitoring dashboard for investigation. 13. How do you configure timer triggers in host? JSON. Configure singleton lock period and recovery settings under Singleton section. Set health monitoring interval for timer-related host health checks. Logging filters can target timer-specific categories for detailed diagnostics. No direct timer schedule configuration in host. JSON. Defined in function. JSON. Attribute. 14. Explain dynamic timer schedules. Dynamic schedules use %schedule $placeholder to reference an app setting containing the cron expression. Enables changing schedule via portal, CLI, or ARM template without redeploying code. Supports environment-specific intervals, dev frequent, production infrequent, with single codebase. App setting value resolved at runtime. Full NCRONTAB syntax supported. 15. How do you handle daylight saving time changes? Use named time zones in website_time_zone setting, e.g., Eastern Standard Time, for automatic DST handling. Named zones apply correct offset adjustments during transitions. Avoid fixed UTC offsets. Schedule evaluation remains UTC internally. Time zone conversion occurs during expression parsing. Test DST boundary scenarios in staging to verify execution timing and overlap behavior. 16. What is the role of run on startup? Run on startup equals true executes the timer function immediately when the function app starts or restarts. Useful for initialization tasks, catching up missed schedules, or one-time recovery after downtime. Configured in timer trigger attribute or function. JSON. Recommended for scenarios requiring guaranteed execution on host startup. 17. How do you monitor timer trigger executions? Monitoring Hub displays timer run history with status, duration, start, end times, and error details. Application Insights tracks invocations, exceptions, and custom events logged from timer functions. Custo queries filter timer executions by function name and status for trend analysis. Data activator or custom alerts notify on missed executions or long durations. 18. Explain timer trigger scaling behavior. Timer triggers do not independently trigger scale out. Scaling driven by other active triggers or minimum instances, premium. Singleton mode ensures single execution even when scaled out to multiple instances. Consumption plan may not scale out for timer-only workloads unless other triggers are active. Premium plan maintains minimum always-ready instances for consistent timer execution. 19. How do you implement recurring background jobs? Use timer triggers with appropriate NCRONTAB schedule for periodic background processing, cleanup, sync, reporting. Ensure idempotency to handle potential duplicate executions safely in scaled environments. Combine with singleton mode for stateful operations requiring exclusive execution. Monitor execution success, duration, and failures for operational reliability. 20. What is the difference between timer and scheduled pipelines? Timer triggers execute lightweight code directly with simple scheduling. Pipelines orchestrate multi-step workflows with dependencies and error handling. Pipelines support complex activities, copy, notebook, data flow, and branching logic. Timers are single function. Timers scale automatically per invocation. Pipelines use capacity-based scaling. Use timers for simple recurring tasks. Pipelines for orchestrated ETL or integration jobs. 21. How do you handle long-running timer functions? Consumption plan limits execution to 10 minutes maximum. Use premium, dedicated plans for unbounded duration. Break long tasks into smaller functions chained via durable functions orchestration. Use durable timers within orchestrations for long-running scheduled workflows. Monitor and alert on executions approaching timeout thresholds. 22. Explain timer trigger in isolated worker model. Isolated worker model fully supports timer triggers with identical NCRONTAB syntax and execution behavior. Worker process handles timer scheduling independently of the main host for better isolation. Improved startup performance and language flexibility compared to in-process model. Configuration via host. JSON remains consistent across both models. 23. How do you test timer triggers? Local development executes timer according to schedule. Adjust system clock or use run on startup for immediate testing. Mock timer info parameter in unit tests to simulate past due or scheduled executions. Integration tests use Azure Storage Emulator for status storage validation. Logstream captures execution flow during local debugging sessions. 24. How do you manage timer trigger costs? Consumption plan bills only for actual execution time. Idle timers incur zero cost. Frequent schedules increase execution count. Optimize interval to balance freshness and cost. Use premium plan reserved instances for predictable costs with high-frequency timers. Monitor execution count, duration, and frequency via application insights. 25. Best practices for timer trigger design. Always use singleton mode for stateful or non-idempotent operations to prevent duplicate processing. Set reasonable intervals. Avoid sub-minute schedules in consumption plan to prevent excessive executions. Implement idempotency, error handling, and monitoring for reliability in production. Use dynamic schedules via %schedule% for environment-specific tuning and test thoroughly across DST boundaries. Thank you for watching. If this video helped you prepare for your Azure Functions interview, please give it a thumbs up and share it with your network. Don't forget to subscribe to ZoomInData and hit the bell icon for more in-depth cloud computing, serverless, and Azure interview prep videos every week. Drop your questions or topic requests in the comments. Let's zoom in on your success together.